I'm going to spend a little time talking about solving word problems using inequalities. Now, these problems are all sorts of different difficulties, and it's primarily because every situation we come across is going to be a little bit different. There is not one size fits all solution to every single inequality word problem because every situation is a little bit different. So what I'm going to do here is I'm going to show you how to do a couple. I'm going to do parts of some of them and let you work out the rest. But just to give you an idea of how to set them up. Okay. So there is a problem that's going to have a context later on that I need you to understand, and it's this. When I say that, for instance, I have these two sets of sticky notes. I say that I have twice as many blue as I have of pink. This is what it means. If you look here, I got 6 of these blue, well, there's 7 here, so let's take one out. I got 6 of these blue sticky notes, right? Oh, look at that, I did have 6. If I have 6 of these, and I say that is twice as many as I have of pink, that means pink I only have 3 of. Okay? So I would have to do 2 times as many pink in order to get the amount of blue that I have. That's going to come in handy later down the road. Now, let's move on with these, and I'm going to show you how you can work some of these problems and set them up. Alright, this first problem. Carlos goes to the fair where it costs $5 to get in and 80 cents per ride. Now we know that per is a good multiplying word, so that means I'm going to have 80 cents times how many ever rides that I ride. So if I say R is the rides, right? So 80 cents times the amount of rides I do. Alright, question A. Write an expression representing the cost of the day after buying X rides. So they're going to use X as our variable, so we can use X as our variable here. Well, it cost me $5 to get in, and then how many ever rides I ride, which is 80 cents per ride, so times X, right? So this is the expression that's going to tell me how much it costs to get in, or how much I spent in the entire day. Carlos is allowed to spend at most, that's important, $25. Write an inequality using the expression you just found in part A. So we're going to have to use an expression. $5 plus 80 cents per ride. Alright, so at most, which of these inequality symbols is at most going to represent? So we have greater than, less than, greater than or equal to, less than or equal to. At most. So if I were to say your grade can be at most 100%, see, that would make sense because you can't get a grade higher than 100. If you do, it's extra credit, but in my class you cannot get higher than 100%. So at most means that is the max amount we can have him go. So if I set $25 here, we want to make it where this cannot be any bigger than $25. So I would say you can either point your symbol towards the $25. $25 has to be bigger than whatever this is. And at most means it can be equal to. I can have exactly $25 worth of rides and ticket costs or entry costs. Alright, now could you have written this in a different way? Sure. $25 at most. That means the most I'm going to spend is $25. So that's $5 entry fee plus the 80 cents per ride. Okay? So either way you write this, you're going to be able to solve it in part C and find out what the value of X is. Now, you know how to solve inequality, so I'm actually going to let you go ahead and solve that and figure out how many rides he can go on. So whatever you solve for X is going to be your answer. Alright, moving on. This one's a little more challenging to set up, and I might have to break up this assignment into 2 videos, but just to give you an idea. Christina bought suckers for her children. She gave Linus half of the ones she bought, but ended up taking 5 away from him by the end of the day due to poor behavior. Write an expression for the amount of suckers Linus received. So she says she gave Linus half of the ones that she bought. So let's use X as the number of suckers that she bought, and we're going to divide it in half, or I could just say 1/2 times X. Alright, but she also took 5 away, so we're going to subtract 5. And so this is how much Linus would have had at the end of the day. Now, she gave Nicholas 1/3 of the ones that she bought. So, and an extra 3. So she added 3. By the end of the day, due to good behavior. Alright, so she gave Nicholas 1/3 of them and gave him 3 more by the end of the day. So write an expression. Well, if X is the number of suckers that she bought, she gave Nicholas only 1/3, but she gave him 3 extra by the end of the day. Okay, so she gave him 1/3, 1/3. When it tells you a fraction of the amount that she bought, it indicates multiplication. So half of what she bought or 1/3. It also implies division. So divide in half or multiply by 1/2. That's the same thing. Divide by 3 or multiply by 1/3. That's the same thing as well. Okay, so you could have ended up having 2 expressions here. You could have had 2x minus 5, x divided by 2 minus 5, or 1/2 x minus 5, or you could have had x divided by 3 plus 3. Okay? So, here's the tricky part. Linus had at least as many suckers as Nicholas had at the end of the day. So, at least, that's kind of one of those key words that you're going to need. So, write an inequality comparing the 2 expressions you found. So we're going to compare these 2 expressions we just found. Let's use the ones where we don't have fractions. Okay, let's use the ones where we're doing division. X divided by 2 minus 5, and we're going to compare that to x divided by 3 plus 3. So how do you compare it? At least, and this is Linus and this is Nicholas. So at least, Linus had at least as many. So he could have had exactly the same amount, but at least implies that Linus had more or equal to. Okay, so I have at least a B in this class. Could I have had an A? Yeah, because the least amount that I would have in the class is the B. So Linus had at least Nicholas's. So Nicholas would be on that lesser part of that symbol. Then it says solve for the inequality. Now this one is really tricky. I am going to let you solve for it, and we can do that together in class. But I am going to let you try and solve for that inequality right there. Okay? Okay, so I'm going to stop here, and we'll do another one.
Part of the